recording going, and let me share my screen. Here we are. Okay, cool. So we're gonna continue on. We got one more. We got a while loop breakout here, and then where are we? Okay, yeah. And then we're gonna get back into strings and kind of pick up from where we left off yesterday. So let me grab this and pop it into Slack. Okay. Oh, Slack, come on. Please apply the formatting. There we go. Okay, there we go. So here's the first breakout. That'll be 8 minutes on the clock. And once you're done, go ahead and put in your answer. Apologies, I just realized that this the prompt says write a for loop. I should say write a while loop. I just encountered another problem. I apologize for that. So there are non-ASCII quote characters, and I just fixed that. Here, I'll repost the food list variable there. The quote characters are, if you look closely, they are actually it's not the same quote character that's on your keyboard. It's a valid UTF-8 character, but it's not an ASCII character, so it'll cause a problem if you try to run it off of that. So apologies for that. I just went in and fixed that in the in our docs there. So. We have some questions here. Is it supposed to take a selection as well? Yeah, so you could do this in a number of ways. It's meant to be a bit open-ended. There are a number of kind of valid ways to do this, but basically we want you to use input to prompt the user for an input, to input one of the food items, and then store the items. And then as far as being able to start this, I would say what I would do is create an accumulator that would just accumulate the user's choices. The user will put in, let's see. Yeah, let's see so the user will put in a number starting from 1 up to whichever, however long the length of the list is, and that will correspond with the element at 1 minus that number, at the index of 1 minus that number, and then you'll store the element in the for loop, or excuse me, in the accumulator, and return it. That's how I would structure this. Okay. I'm not seeing any answers at the moment. We did give 8 minutes for this one. I do want to keep us moving forward, so I think I'm just going to show a solution. I'll just paste the solution that they give. Go ahead and just paste in whatever you've got. This, by the way, this is we used to have these challenges written in a Google Docs, Google Slides context, and this is kind of, I'm realizing, one of the old challenges that kind of got copy pasted over, and I am realizing we'll need to update it. So apologies, this one's a bit older, a bit vague. So okay, let's just do this and clear that out. And there we go. Comment. Okay, so this is the code that they give. Oops, and I've got to go fix this in 2 places, evidently. Okay. This is saying, this has this wish to continue variable. This is just saying while wish to continue equals yes, we're going to print selection, and then this is running a for loop, enumerating each element in that list, in that food list, just printing it off. There's a number of ways to print this list off. And then we've got, order? Oh, I always put my accumulator right up top, so kind of got lost in there. Order.append the food item, and then we take input from the user. We prompt the user with choose an item by its number. We prompt the user for an input and take an input, cast it as an integer, subtract 1 from that because the first element we're calling 1, and then appending that index from food list into the order list. And then we ask the user if they wish to continue, and if it's a yes, then we continue, and if it's anything other than a y, because that's what we're checking for here, then we're going to stop. I kind of like doing something. My own preference would be to say if input choose another item, yes or no, and then say if input equals n, we could do this. If input n or n, or we could do q or q2, something like that for quit, and then we can break. Of course, that means I'd have this while true here. Just get rid of that flag we don't really need. Just a personal preference, though. That's kind of how I'd write it. So let's just run it, see what it does. So you can see it's going to print out the menu. So let's say I want to order waffles. I'll say 4, another item, and then I want to order sausage. We'll say 6, another item, and let's say omelet, and we'll say no. Waffles, sausage, and omelet. Makes them with breakfast. All right. I'm going to make a note to go back and edit that challenge. Apologies, it was about it being kind of rough around the edges. Okay, cool. So let's get back into strings. Last time we just touched on enumerate, and we had replace to go over as well. So shifting gears into strings, Let's talk about the replace method. So this is kind of a funny one because replace, you're thinking about mutability. Replace sounds like it's a mutable operation, right? So let's do a little thing here. Let's say text equals I'll copy their text. I'm trying to think of an example, and there's an example right here. I love to look at the moon, and then we can say text dot replace. I'll just do what they're doing. I'll say replace O with puppy. Okay. So if I print text, what am I going to get? Or why don't I, let's say, instead of, I'll replace O with just capital U, like that. So if I print text, what am I going to get? Go ahead and put it in Slack. We'll take a minute for this one. Okay. So, I want you to notice, I think we got basically unanimous. Yeah, everybody put in the same answer, I believe. Nope. Sorry. A couple people put in a different answer. Okay. So most people put in a different answer in this. So, I want you to notice that you made this assumption. It's fine to have assumptions. It's useful to notice that you do make them and what they are. So it's easy to look at this. I want to be very clear about what's happening here, right? I initialize this variable. I call this method on this string. Now remember, strings are immutable, right? So the assumption that most people made is that just by calling this method, it would change the string, which is the definition of a mutable operation. So what replace does is it returns the value. So this is a bit of a test of your intuition, and it's an opportunity to get that, to help establish that idea of mutability versus immutability, right? So there's no method or operation that we can do to any string that will change the string other than to create it or destroy it. We can create it and we can delete the whole string, or we can reassign the variable, in which case it's going to be an object, an orphaned object, which will get cleaned out of memory eventually. But we can't change it. I just create it or destroy it. So if I run this just like this, I'm going to get this. So notice the U's have not been, or the O's have not been replaced with U's. So I'm not trying to put anybody on the spot about this. I figured some people would make this assumption that the O's would be replaced, but I wanted to do this to show you, and I think this group actually has a really clear idea for the most part when I'm talking about mutability versus immutability. I think it's actually It seems like it's landing pretty well for the most part with people. Like this concept is making sense, which is great because it can be a weird one. So notice, even still, it's easy to make that mistake. It's easy to say, oh well, that's the behavior that I expect. Now, the real way around this is I'm not trying to how do I put this? I don't want to create the sense that like you have to assess this kind of thing correctly every time perfectly. You have to know the difference you have to know what an immutable behavior is and an immutable behavior is. You have to know the differences between those two behaviors. If you forget sometimes, well, I mean, I forget sometimes. The real antidote to like maybe being unsure about something in a given moment is to run your code. When in doubt, print it out. When in doubt, just run your code, ask the Python interpreter, get creative, and start thinking of ways that you can get the Python interpreter to give you information. There's things constantly where like there's a lot that I don't know, and there's a huge amount that I learned once or twice and then forgot about that I don't use on a daily basis, so I just kind of tuck it away, and then when I want to come back around to it, I kind of remember the concepts, but I forget the implementation details or maybe some of the details or whatever. So I got to go figure it out again. So I'm constantly like figuring things out that are similar to things I know or things I used to know or just different than things I know. And the way to do that is just running your code, which I robbed you of because I was trying to play a trick on you. I didn't run the code. And if I had ran that code, we'd have had our answer right away. And that's totally fine. In your own code, obviously I'm trying to provoke a certain kind of thinking and noticing of your own thinking in this. But when you're writing your own code, it's never cheating to run it if you don't know what's going on. You're not robbing yourself of the opportunity to think through it. You're giving yourself the opportunity to practice working with the interpreter and getting the interpreter to give you useful information. Okay. So the question remains, how and why is replace useful? If I can't use it this way, well, how can I use it? Well, like I said, it returns the value. It returns the value. It returns an altered version of the string, but it's not, well, how would I put this? Altered makes it sound like it mutates it. It returns a version of the string, a different string with those characters replaced. So why don't I print that out? We'll do a before, during, and after. So we're going to get, I love to look at the moon, and then boom, 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 boom. There we go. There we go. So that's what we're going to get. So kind of the cool thing is, and I know I've given this example before, right? But if I want to perform this operation and I want it to feel like it changed the data, if I do want that behavior, well, I can get whatever this returns and assign it to the same variable that held the old version, and it's like fake mutability. This is not mutability because what we've done is we've reassigned the pointer to a different object, which is not what happens in a mutable operation, but it has a very similar effect. In your code, for an accumulator or for something where you want it to save a modified version under the same name, then this works, and it can fill a similar niche in a lot of cases to mutability. Run some quick tests. Yes, indeed. Did I ever tell you how much I love tests? Let's make all of today's class about me talking about tests. I'm kidding. Is there a simple reason why strings are immutable but lists aren't? Is there a simple reason? Well, I believe some languages do have mutable strings. But I think there's also, or they have, I'm aware of a language that has two string types. One is a mutable type and one is an immutable type. But I was thinking, I find it kind of silly because you can always cast I mean, I like the Python method where lists are the sort of canonical indexed mutable type, and then anything that you have that you need a mutable behavior from, you can just cast as a list, like a string or some generator or something. You can put whatever you want in the list, do the mutable operation, and then likely there's a pretty easy way to cast it back to whatever you need it to be. So, I mean, I guess the short answer is if you really needed a mutable operation, you could cast a string to a list and then do the mutable operation and then cast it back to a string. So you don't really lose that behavior. But by casting, casting it from a string to a list and then back to a string again could be, if that string was like really huge, could have a significant performance impact, well, a memory impact, because at least for there's likely to be 3 versions of that data at some point, although one of them will probably be cleaned up. 1 or 2 of them will eventually probably be cleaned up. So if that memory duplication is a concern, then I don't know, that's maybe something you have to live with, but or find a different way of doing things, or just accept that, oh, Python strings aren't mutable and I'm taking a performance hit because of that. Too bad. Honestly, like I don't see that as a very feasible limitation. I can't see that being that difficult. So the short answer is to avoid unnecessary bugs. That is the short answer. Yeah, actually, yeah, that's a good way of thinking about it. Like, if let's say you're making a new data type, which as you get into object-oriented programming, that's eventually what you're going to be doing. You'll have a choice to make your types mutable or immutable. And the default option in most workflows and most paradigms is to make an immutable object, and only make a mutable object if you kind of don't have another choice, right? So you'll notice even amongst the Python default types, there are more immutable types than mutable ones because it's sort of safer. They also have a smaller memory footprint. It's easier for your memory to allocate space to an immutable type because it knows from its inception, it knows what its size is. So it doesn't need to figure out, well, if this thing needs to change in size, how would it do that? It can just say, oh, well, this takes up 200 bytes. Well, I'll just lay aside 200 bytes for that, and then I'll put something right on next to it. So there doesn't have to be any other additional logic to, like, okay, where are we gonna put this? If it changes size, where are we gonna put that? If it grows in size, where are we gonna stick that information, and how are we gonna know it's part of the same type? Do you just lay out more information, more RAM than you need? What happens if it grows out of that? Do you move the whole object? So like figuring out how to store an object in your memory. I mean, you can start thinking through things like that. Figuring out how to store an object in memory just that can change size, that's mutable, just has a lot of additional challenges. Whereas if you have a guarantee that it won't change its size, it's very easy to deal with. So, okay. Anyways, so it sounds like there's a preference for things to be immutable, and mutable types are the special case. Yeah, that's a good way of thinking about it. It's like it's a mutability is powerful by definition, but it's I mean I think about it as very much kind of a similar thing to for loops and while loops. Like while loops are more powerful, but they also come with some problems. You need them when you need them, but if you can get away without using them, it's easier to do that. So, okay, cool. I said I would cover enumerate again, and I will. Sorry, I was just debating that. So this is in the context of strings. I'm just going to cover it in the context of strings and lists. We're usually enumerating lists, but you can iterate through a string or a list or whatever. So let's do, well, shoot, I'll just do this. Okay, we'll start with this list, and I can say for IDX and element in food list, we can print IDX. Let's do this, F. Okay. Oh, I forgot to do enumerate, which is the whole point. Okay, there we go. So the enumerate function is used, I think it's safe to say, exclusively in this part of for loops. I have seen enumerate used occasionally outside in other contexts. We don't really need to understand those contexts now. They don't come up that often. So when most of the time we're using enumerate, we're using it in the source of a for loop, the source of things to iterate through, right? So enumerate lets us name a second identifier. It gives us back 2 items at a time, the index followed by the element for each iteration, for each element in the thing we're enumerating. We always think of this, or we almost always call this and think of this enumerated, this number, as an index. We usually will just call it IDX for index. But we can actually start it wherever we want, and it's just a counter. It doesn't do anything special to like extract the index from the element. It just starts a counter at 0 and then continues the counter through the list, right? So we can start that counter. We have an optional second argument to enumerate, which is wherever we want to start that counter. So I want to start it at 4. I don't know why I would, but we can start pancakes is 4, 5 is omelets, 6 is toast, etc. Right? It started at a negative number. So you can start that counter wherever you want, and sometimes that's useful. Sometimes it's useful to like start it at 1 or something, and you can tune exactly where that is. So yeah, that's enumerate. I could also do, I could enumerate just a string as well. You can see this, I'm just enumerating the string pancakes are good. Pancakes are good. So you can enumerate a string as well, and that's all that this is giving us an example of. Okay, cool. Let me grab this. We got another breakout. There you are. I'm going to put 5 minutes on the clock. Okay. So I'm just going to show a quick solution for this one. Okay, so write a function that takes a list of the following, list like the following, list of column names, and change any spaces in the column names to underscores. Return the modified list with the updated names. Okay. So let's say we're going to print, and I'm going to say snake caser. So I'm going to call it snake caser because snake case, which is what this is underscore separated words. It's called snake casing, and it's what Python uses, kind of oddly enough. Def. We're going to say, so snake caser takes in list columns list. Actually, yeah, we'll just do that. And it will for let's say I'll just say text and columns list. You know, I just want to call it list. So for text and list, I want to have an input list. Excuse me, this is my input list. Geez. And we'll have an out list. So this will be my in list and my out list. And we're going to do return out list equals list. And for every text in list, I'm going to out list dot append text dot replace space with underscore. Okay, cool. I'll do it. This just has an extra check here just to see if there is a space in the column name. Yeah. This is also doing what would I call this? This is not an additive style accumulator where you're accumulating into a list that was empty. What's happening here is we're copying the original list and then modifying the indices according to that. So we're updating, oh my gosh, sorry. We're updating each location in that list. This works about exactly the same as this. In either case, we have a memory footprint of two basically equal size lists of strings. My code, the reason I would rather do it this way is it's just such a vanilla way of doing things. You know, just empty list, add in correct element. I don't have a condition to check. I don't have to do anything fancy. I don't have to do item reassignment. And I end up with something that still produces a duplicate list. Whereas this has a little more weight to it, I think, but either approach is really fun. We end up at the same place. Okay, cool. So let's do this. Let's talk about the list function. So if I have a string, I'll call this text, equals, we'll just do this, hello, and if I print text, am I going to get, oops, if I print list, I was going to try to make a little impromptu breakout for this, but let's just go for it. So if I cast a string to a list, each character in that string will be its own individual element in the list. This kind of ties into what I was talking about earlier, being able to cast a string to a list. If I needed some mutable operation to happen, if I needed to rearrange characters or something, you know, it's pretty straightforward to just cast the string to a list and do your operation. And then if you wanted to cast back, you could, or whatever. Can I scroll up so I can see the multiple method application? Maybe, do you mean, I'm not sure which frame you want me to scroll up in. Multiple method application. Are you talking about here? Oh, is it? Okay. Why don't I do this? I should have pasted these in. There's my solution up top. And here's the given solution. Oh my gosh. The append with the nested replace, cool. Yeah, I meant to actually paste those anyways, and I just spaced it, so good. All right. The list function. The split method. Okay, so list and split kind of go together because these are two different ways. Most of the time most of the time you think, oh, I need to turn this string into a list. What you probably want to break that string up probably on words. You want to break it into a list of words, maybe on sentences or paragraphs or something. You have something that is delimited by some character that's meaningful in the punctuation or whatever in the delimitation of words for that language, such as a space or a new line or a period or exclamation point or whatever, maybe a tab, it could be anything. So you usually want to break it up on that basis rather than on the basis of each character, right? So usually what we'll want to do is use split. And you know, because I say usually, and these are not alternatives to each other. They just do different things. I find that most of the times that I have the thought I need, you know, something string something list, that leads me to split. What I'm really thinking about is split. And the reason I'm framing it that way is I think I hear a lot of people say, oh, if I could only iterate through the words, and then they'll cast it to a list, and they'll say, wait, how do you do that? So split is usually the answer for that. We talked about split with split and join. So split and join are kind of inverse operations of each other. They sort of undo the other one. You usually, or I don't know usually, but often when you see split, you will see join later, or the other way around. Often where you see a split somewhere, you're going to see a join somewhere else, or a join somewhere, you'll see a split somewhere. So split and join often go together. So yeah, so I want to split this on words. I can just do split like this, and that'll work. I'm gonna just quickly grab, oh, this is what I wanted. Oh, no, I'll actually do this whole thing. I know I gave this example before, but split is so useful that it's worth covering again. So here's our text. We have some body of text. If I want to print a list of words, I can say text.split. This will split on, oh, text, there we go. This will split on white space. So if I don't pass anything split to split, it splits on spaces, new lines, and tab characters. Those are the 3 white space characters. Let's say I wanted to split on, I don't know, how about E? Like that, right? So I could split on the character E. Notice there are now not going to be any E's represented inside of this. If I wanted sentences, I could split on periods. Earlier I had said you kind of have to do some work if you want to split on multiple things. So one thing you can do, I could, let's say, because I have these question marks here, if I want to split on question marks as well, one thing I can do is text.replace question mark with period, and then I can split on periods, and then you'll see I have that where that question mark was. I have that split out. So for every character that I would want to split on, I might do a dot replace. So text.replace question with dot text dot replace. Let's say I don't think there are any exclamation points, but we could replace exclamation point with dot, and then split on that dot, and then that'll split on all those places. Joining that back together, where you can joining it back together with the, since we lost the question marks and the exclamation marks and the periods, when we join back together, we can only choose one delimiter. So if we split this and then join it, there is going to be some information loss. So if that's acceptable, then great. If it's not, then you have to find something else to do. This pattern doesn't come up a whole lot, but I've used it and it's a useful pattern. So replace can be good if you're like, oh, I need to split on multiple things. You can't split on multiple things, but you can replace the second thing you want to split on with the thing that you're actually going to split on, and then you effectively split on multiple things. But just know that that comes with a little bit of information loss, probably, when you join again. Okay, cool. So case transforms. Let's just do this one again. Okay, here we go. And so let's say we're just going to take a little sample here. Just call this text equals this, and we'll print text. We'll print text dot lower. You may well be able to guess what these do. Upper capitalize. Swap case. If there's a use for swap case, I don't know it, and I've had some conversations with people, multiple people, who are just like, do you know any use for swap case? it's a method that's there. I'll show it to you in a second, but lower, upper, and capitalize are worth knowing. I think actually there's another one that I used recently, title. Is it title? Yeah, title. Title can be a good one. Lower, I use like all the time. Lower, there's sort of a, I think you could technically use lower or upper for this task, but people will tend to just use lower. You'll see me do this. There's a lot of times you want to, I'm thinking about like a check for membership. Like if I want to check if some character is a member of some string, and and the character that I'm checking is in a variable, maybe it's in a for loop, in a function. So I don't necessarily know, I don't have a for sure certain knowledge of what that character is. It could be an uppercase or a lowercase character. I kind of handled this in a different way with this while loop challenge that we started off with, where I said, you know, choose another item, Y or N, and I included this, and I'm checking for membership depending on what input gives me. I'm checking for membership if I get a lowercase or an uppercase N, right? So usually, honestly, I don't do this when I do this kind of check for membership. What I'll do is I'll say dot lower. So it's more likely that I'll say, you know, imagine I have 4 ch in some, oh, I was just going to say some string. You know, I got a string right here. Okay, in text, we'll do big text. No, let's do little text. 4 ch in text, we could say, let's just see if it's a vowel. So we'll say if ch in A, E, I, O, U, then ch, we'll just print ch, right? Okay, so here's the problem. You know, notice the first one I get is this I from Miles, but here's an A right here. This A is a capital A, so I could do A, E, I, O, U. What's more often done, and what I tend to prefer to do, is to do ch.lower. Even though this might be a few more characters, it's not as short or whatever, it like captures the idea of thinking about this as like, okay, I want the lowercase version of ch, make sure, it's sort of like I'm explicitly making an effort to standardize this character to ensure that it's a lowercase character. That way I don't forget to like put in the lower and uppercase version of everything. It might be kind of weird, so. Anyways, so if ch.lower in AEIOU, and now if I run this, it'll print that A, right? So you use lower all the time for this kind of thing, for case standardization. You use it like as a tool to ignore case. So anytime you think, oh, you know, I have to do something with a string, and you know the characters matter, but I don't care about the case. I need to ignore the casing. Just make sure you're doing dot lower on, you know, whatever comparison you need to make, that each one is in a lowercase form, and then you can ignore case that way. So I use dot lower. Technically, we could use dot upper for that as well, but it's always lower, you see. So anyways, there's our original text. Here's our lowercase version. Obviously, it's all lowercase. Here's the upper case version. It's all uppercase. It's all caps. Title capitalizes every word. Capitalizes only the first character. You might think, oh well, maybe it'll capitalize the a character like after a period. You can see it does not do that. Does not capitalize a character after a period. it just capitalizes the first character and nothing else. Oh, and excuse me, it capitalizes the first character and it lowercases everything else. So notice in this capitalized line, I should like copy each of these so that it's more obvious, right? So I'll show you like this. I find capitalized to be kind of finicky, and I don't use it that often, to be honest. So notice it capitalized the A, and it lowercased the I. So anything that was capitalized is now lowercase, except the first character is uppercase, and the lowercase is everything else. So that's capitalized. Swap case. I'm going to show you swap case because it's here. Like I said, I don't know a reason for it. It does what it sounds like it does. It just makes the lowers uppers and the uppers lowers. Like I said, I'm not sure why it exists. I think it's what I suspect is that Python started as like an easy language for kids, and the developer, the original creator of Python, was just like, oh, this is just like a toy project that I do on the side, you know. It'd just be a good like first language so kids can get started with programming. And it was meant to just be like a gentle, easy language to learn, and it is. It's just that it's also really powerful, and people were like, actually, well, you know, why would I do this in a language that's not as pleasant to work in if I could do it in Python, you know? So it caught on and people liked it, and now it's taken very seriously, obviously. But I think there are things every now and again where there's like methods or little things that I think are holdouts from just like, here's like a random thing you could do, you know. I think swap case was just like, here's a fun method that you can make a string look silly. It's just like a thing to add. That's why I suspect that it exists. So it's not something that you have to memorize. Okay. String formatting. Okay, we're about halfway. Let's take a break. Let's see if we do. Let's reconvene at 12 minutes after the hour. Okay. Let me see here. Check, check. Okay. Looks like we got a question here. We can open up a little bit for questions. I could do like one or two more if they're quick. Then we'll jump back into things. We're almost through this actually. So somebody's asking, I'm assuming there isn't a method like capitalize that capitalizes the first character in a sentence but doesn't change casing on other characters in a sentence. For example, where the I stays the same as I. So it would just enforce capitalizations after periods. It sounds like that's the behavior. So I think there is not a method like that. I'm like almost certain that that's the case. I'll show you how to find out though. You've seen me do this. You can do dir, let's get the directory of string. It's gonna give me all the names of all the string methods, and you can kind of look through here. A lot of times, you might see, you have an idea of what you're looking for and you read the name and you're like, oh, that probably does what I want. Or you'll read a name and you'll see, oh, that probably does, is lower. Can you guess what is lower probably does? My guess is that it returns true or false as to whether a string or character is a lowercase character or not, or lowercase string. So things like that, right? So it's always good. It just keeps you familiar with whatever methods are available to. So capitalized, casefold, center, and some of these I've never used. I don't know what they do. Some of them I use all the time though. So encode ends with expand tabs formatting. So you could go read through here and see if there's something that'll fit what you want to do. I think it wouldn't be that hard to write something that does that if you have a clear idea of what you're trying to do. So the idea was enforce So enforce capitalization at the beginning and after a period. So I could write def and let's call it better capitalize. It'll take in text and we'll return, I'll just do an accumulator. I'll say accumulator equals empty string for ch in text. Let's do trying to think of how to do. I think I'll just do IDX. We'll enumerate. It's easy. I think there might be a little bit of a better way to do this, but this will work. I'll say if IDX equals 0, ACC plus gets ch dot upper. Else we'll just do ACC plus equals ch. So we'll say if IDX equals 0 or there was a period, if ch, no, we need a different channel for this. We'll say if ch equals period, we'll do a Boolean flag. Say flag equals true. Actually, I'll do false. I'll swap my flag. And here I'll check my flag. If flag, if flag and ch not equal to a space, because we don't want to capitalize a space. We'll say flag, we'll reset our flag, and we'll do ch.upper. And it occurs to me, this is really one condition. Yeah, okay. There's ways that I could clean this up, but I think this will work. I think this will enforce capitalization at the beginning and after a period. So let's just try it out. And I wanted to just write it out because to show you, you know, like you're like, dang, I wish there was something that did that. There's a little bit going on here. You know, there's a little bit going on here, but it's not terribly complicated. Hopefully you agree. So let's try this. Print, better capitalize. We'll take in text, and I'm actually going to make text.lower just so that I'm certain that everything's a lowercase character. So let's see if I got any errors. It did run. Let me do this. ch not in space, and I'm just going to include white space new line and tab. That makes sense to do it that way. Oops, not in. Okay. We are duplicating that character. So I just have to have an else. I have to have these multiple else's. Okay. It's a little bit. I could definitely, this could be cleaner, but I'm just trying to do this real quick. Okay. I've got some bugs in there, but I think it's 90% there. I want to move on. I have this duplication where I'm doing the upper and the lowercase for elements after periods. And of course I want the periods. I will need to do that as well. What? Okay, I got myself into a confusing spot here. I'm going to move on, but anyways, there's that. Let's just jump into this breakout here, and I'll see if I can get that to work really quick. There we go. Okay, cool. So there's our 8 minutes. I'll show a solution for this one. Okay, so write a function that takes in a string, return 2 parallel lists, one that contains unique characters in the string and another that has the same number of times that the character appears in the original string. Oh gosh, this is another one of those. Okay. Write a function that takes in a string, okay. Return 2 parallel lists, one that contains the unique characters in the string and another that contains the number of times that character appears. Okay, so let's call this def string, or let's call it chars counter. We'll take in text, pass. I want to write a little test. I don't know, I'm not going to go through and figure out what the output should be based on this. We'll just pass it s real quick. But we should know, it should be fairly obvious if it's accurate. So we'll call this unique chars, and we'll set this to a list. And I know I'm going to return unique chars, and we'll call it char counts. There's another list like this, and I'm just going to do one and then the other. That's all I'm going to do. So for ch and text, if ch not in unique chars, oops, not in unique chars, we're going to unique chars dot append ch. Okay, let's try that. So basically all I'm saying there is if it's not in there, then I want to put it in there. And if it is in there, then I don't want to put it in there. So for the char counts, basically, I think what we can do, I might want to do it like this actually. I want to have a second for loop and say for ch and unique chars. Then we can initialize our oh, that's not going to work. See, I know I can't use the count method because that's what's up next. I would do this with the count method usually, but that makes things extra difficult. I'll show it with the count method in the interest of keeping things brief. So we'll say unique chars equals this, and we'll say chars count dot append text dot count ch. Okay. And of course I'm going to want to do that in there so I don't do things redundantly. Okay, there, that makes way more sense. Let's see what they did here. They have a couple solutions. So this is without the counts, the count method, right? So the count method just makes this a lot easier, and we're gonna get to that in the next one here. So hopefully this will give you an appreciation of the utility of the count method because it makes things so much easier. Okay, so here we have get letter count takes in a string. We've got letters and counts, which seems like basically what I have here. We have for let1 in string index equals 0. If the letter not in letters, that's our letters, same thing here, then we append it, and we append a 0 to counts, and then we set index equal to len of the letters minus 1. That's interesting. Wonder how that's going to come in. Then, so this is if the letter's not in there. If the letter is in there, we have this else. Oops. We have this else, which will take us down this second channel here. This will say IDX and letter 2 in enumerate letters. If the outer letter is equal to the inner letter, so we're enumerating, or we're iterating through all the letters in the letters list in this for loop, while let1 is still equal to whatever it's on, and we know it's already in there, right? Then we check if they're equal. We assign IDX to index. I'm not sure how that's helping anything, and break, and then we do. So this whole thing is meant to acquire the index basically, and then we use that index to find the correct location in counts and increment it accordingly. Imagine something similar is going to happen here. Oh no, this is going to be actually pretty different. So letters.index. Oh, that makes a lot of sense. That makes a lot of sense. This is much simpler to understand. Here we have the same, basically the same for loop, or excuse me, the same base condition. If the letter's not in letters, we append it. And in this case, we're going to start counts equal to 1 because we know there's at least 1 in there at that point. We append that 1 to counts, and then every time we encounter a letter that is already in here, we want to get the index of that letter from letters, because the counter corresponds, the counts list corresponds across its index to the appropriate letter, right? So if we encounter an H and an H is already in there, we want to get the index of that H, and its index will be the same, the count of H's will be the same index in counts as the H is in letters. And then we'll increment that by 1. Oops. Then return and print, etc. Cool. Somebody's asking, or saying, originally I was trying to do multiple for loops as well. Count is much easier, lol. Yeah, count is a very useful method. I always kind of overlook the index method. I feel like I don't use it that much, because a lot of times I think, oh, I'll use it, and then it actually won't do what I want it to do. But yeah, it's a cool thing here, but still it's either you're using count or you're using index. So you can see it gets pretty convoluted if you try to not use count or index. It's starting to get pretty kind of beefy there. Okay, count. So count, we covered this for lists, and it works for strings as well. Count will give you the number of occurrences of a given element in a collection. So, and it gives it to you as a number, as an integer, right? So if I want to know, if I have some string and I want to know how many A's are in that string, I can do string.count A. That's how it's going to work. If that element that I'm trying to count is not in the string, then it's going to give me 0. Applying count to the letter counter. Yep, so this is just going to be basically, this is exactly my code except without the else continue. Okay, cool. Oh, we made it through another slide. Okay, we don't have, we've got 20 minutes. That's still worth opening up another one. So let me grab another slide here really quick. It'll be more strings. Oh, we'll just go through more strings. Just pin that. 8, 9, 11, 11. Okay, cool. Go through the review next time. All right, and I'm guessing, okay, we've just got just this one breakout, so that's all we've got here. Got a big one. Here, let me actually do it like this. Let me make sure this is actually going to be valid. Python. Oh no. What is happening? Okay, that's very strange. I'm just going to have to copy this from the raw text. Should have done that anyways. What the heck was with that, but whatever. All right, there you go. There's the prompt. Have at it. I'm going to put 10 minutes on the clock. Okay, that's time. Go ahead and put in whatever you've got at this point. I'm going to show a quick solution and we'll probably wrap up a little early. Okay, cool. So I'll go through the problem statement here. So create a function takes in a string. Done. This function should split the string into a list of lowercase words. So there's sort of a bit of an intentional misdirection here. We will be splitting this string, but we won't necessarily use that as the output. It'll split the string into a list of lowercase words that make up the string, return a list of unique cleaned words. So unique meaning that they can't appear in the output more than once, and cleaned meaning cleaned according to this. Okay. Challenge strip away any punctuation for now, commas, periods, etc. Challenge remove the common English words from the list below that you're returning. Okay, cool. So I've got this list of list of characters that I want to remove. So I can say for I'll call it punct n punctuation list, remove punctuation list. I'm going to say text equals text dot remove, excuse me, replace. We're going to replace punct with nothing. We're just going to essentially delete it. So this is that sort of fake mutable operation. I will lowercase everything right out of the gate, so I'll say text equals text dot lower. So we have a lowercase, oh my gosh, L-O-W-E-R. Okay, there we go. Typed the characters in the correct order. Okay, so that should remove my punctuation and lowercase everything. I'm just going to run it and just see if it did what I needed it to do. Oops, we got something. String to use. Oh no. Invalid syntax, eh? Okay, here we go. Oh, this must have been from something else. Okay, so it's all lowercase and all the punctuation is removed. Great. So now I just have to accumulate. I got to iterate through this and accumulate all the words that aren't in this list already and aren't in this list already. So that's it. So we'll just say for word in text dot split for word in text dot split if word not in let's see, how should I do this? Yeah, okay, I'm trying to be fancy about this. If word not in list and word not in remove words. Oops, and I should this list. Then we'll list dot append word. Should do it. Okay. So this list contains all the words. We could even join this in a list of words. Let's do string space dot join this, and we'll get another string out. So all the words, now it's a string of unique words that are not common words, that are all lowercase and have all the punctuation removed. So nice clean string that'll kind of give us a signature of the words that appear in the input there. Cool. All right, we'll wrap up there. We've only got a couple minutes left, so it's not common that we end early at all, but we'll wrap up there for now. And yeah, feel free to hang out for questions. Let me stop the recording and we'll open up for questions.